Pip, pip installs packages, is the package installer for Python. Here are some key pip commands. 1. Install a package. Pip install package_name. 2. Uninstall a package. Pip uninstall package_name. 3. List installed packages. Pip list. 4. Check for outdated packages. Pip list outdated. 5. Upgrade a package. Pip install upgrade package_name. 6. Search for a package. Pip search package_name. 7. Show information about a package. Pip show package_name. 8. Install a specific version of a package. Pip install package_name == version. 9. Install packages from a requirements file. Pip install our requirements.txt. Some additional options. H or help, show help message. V or verbose, increase verbosity. Q or quiet, decrease verbosity. Proxy, specify proxy server. Example usage. Pip install requests. Pip uninstall requests. Pip list. Pip list outdated. Pip install upgrade requests. Pip search requests. Pip show requests. Pip install requests == 2.28.1. Pip install our requirements.txt. Note, pip is the standard package manager for Python, making it easy to install, update, and manage packages. Python pip. What is pip? It's the standard package installer for Python. It automatically downloads, installs, and manages Python packages from the Python package index, PyPI. It simplifies the process of adding new functionality to your Python projects. Key features. Easy installation, download and install pip using a simple command. Package management, install, uninstall, and upgrade packages effortlessly. Dependency resolution, automatically handles package dependencies, ensuring compatibility. Virtual environments, create isolated environments for different projects, preventing conflicts. Package indexing, access a vast repository of packages on PyPI. Basic usage. Install a package, pip install package_name. Uninstall a package, pip uninstall package_name. List installed packages, pip list. Upgrade a package, pip install upgrade package_name. Additional commands. Search for packages, pip search package_name. Show package details, pip show package_name. Check for updates, pip list outdated. Install from a local file, pip install path /to /package.tar.gz. Best practices. Use virtual environments, create separate environments for different projects to avoid conflicts. Check package compatibility, ensure that packages are compatible with your Python version and other dependencies. Use requirements files, manage package dependencies using requirements files. Keep packages up to date, regularly update packages to benefit from new features and security fixes. Common issues and solutions. Package installation errors, check for network connectivity, permissions, and package compatibility. Dependency conflicts, use virtual environments or manually resolve conflicts. Permission issues, run commands with administrator privileges if necessary. Outdated packages, regularly check for updates and upgrade as needed. Example. Python. #install the NumPy package. Pip install numpy. #import NumPy in your Python code. Import numpy as np. Conclusion. Pip is an essential tool for Python developers, providing a convenient way to manage packages and dependencies. By following best practices and addressing common issues, you can effectively leverage pip to enhance your Python projects. Python try except. Purpose: handles potential errors, exceptions, in your Python code. Prevents your program from crashing and allows you to gracefully handle unexpected situations. Basic syntax: Python try hashtag code that might raise an exception. Except exception type. Hashtag code to execute if an exception of type exception type occurs. Except another exception type. Hashtag code to execute if an exception of type another exception type occurs. Else. Hashtag code to execute if no exception occurs. Finally. Hashtag code to execute regardless of whether an exception occurs. Key components. Try, block of code that might raise an exception. Except, one or more clauses that specify the exception types to handle and the code to execute if they occur. Else, optional block of code that executes only if no exception occurs. Finally, optional block of code that always executes, regardless of whether an exception occurs. Common exception types. Value error, raised when an argument has an inappropriate type or value. Type error, raised when an operation is applied to objects of inappropriate types. Name error, raised when a variable or function is not found. Index error, raised when an index is out of range. Key error, raised when a key is not found in a dictionary. Zero division error, raised when a division operation is performed with a divisor of 0. File not found error, raised when a file is not found. Example: Python try number 1 equals int, input, enter the first number. Number 2 equals int, input, enter the second number. Result equals number 1 / number 2. Print, result, result. Except. Zero division error. Print, error, cannot divide by 0. Except value error. Print, error, please enter valid numbers. Best practices. Be specific. Use specific exception types to catch only the exceptions you expect. Handle exceptions gracefully, provide informative error messages and try to recover from errors if possible. Use finally for cleanup. Use the finally block to perform cleanup tasks, such as closing files or releasing resources. Consider custom exceptions. Define custom exceptions to represent specific error conditions. Additional notes. You can use the raise keyword to raise an exception manually. The except clause can catch multiple exception types using a tuple. The as keyword can be used to assign the exception object to a variable for further inspection. By effectively using the try except construct, you can write more robust and resilient Python code that can handle unexpected errors gracefully. Python user input. In Python, you can get user input using the built-in input function. Here's how. 1 basic input. User_input equals input, prompt. 2 input with default value. User_input equals input, prompt, or default underscore value. 3 input as integer. User_input equals int, input, prompt. 4 input as float. User_input equals float, input, prompt. Some best practices. Always provide a prompt to let the user know what input is expected. Use try except blocks to handle invalid input, example non-integer input when expecting an integer. Consider using input, with a default value to provide a fallback option. Example usage. Name equals input, enter your name. Age equals int, input, enter your age. Height equals float, input, enter your height, in meters. Print, f name, name, h, height, height m. Note, the input function returns a string, so you need to convert it to the appropriate data type, example int, float, if necessary. Purpose. Allows your Python programs to interact with users by accepting input from the keyboard. Enables dynamic behavior and customization based on user preferences. Key functions. Input. Prompts the user for input and returns it as a string. Takes an optional prompt message as an argument. Basic usage. Name equals input, enter your name. Print, hello, plus name plus. Data types. The input function always returns a string. You may need to convert the input to other data types, example integer, float, using functions like int, float, or eval. Example. Age equals int, input, enter your age. If age equals 18. Print, you are an adult. Else. Print, you are a minor. Best practices. Provide clear prompts, use informative prompts to guide the user and avoid confusion. Validate input, check for valid input formats and handle invalid input gracefully. Handle exceptions, use try-except blocks to catch potential errors during input conversion. Consider user experience, provide helpful feedback and error messages to improve the user experience. Additional tips. For more complex input handling, you can explore libraries like argparse for command-line argument parsing. Be mindful of security vulnerabilities when dealing with user input, especially when accepting sensitive information. Conclusion. The input function is a fundamental tool for creating interactive Python programs. By following best practices and considering user experience, you can effectively incorporate user input into your applications. Python provides several ways to format strings. Here are some common methods. 1. F strings, Python 3.6 plus. F hello, name. 2. Str format. Hello. Format, name. 3% operator. Hello, %s. %name. F strings are the most modern and readable way to format strings. They support various formatting options, such as variables, f name. Expressions, f2 plus 2. Formatting specifiers, f value .2f, float with 2 decimal places. Some formatting specifiers. S, string. D, decimal integer. F, floating point number. X, hexadecimal integer. B, binary integer. Example usage. Name equals John. Age equals 30. Hashtag F strings. Print, F hello, name. You are age years old. Hashtag str format. Print, hello. You are years old. Format, name, age. Hashtag %operator. Print, hello, %s. You are %d years old. Name, age. Note, F strings are the recommended way to format strings in Python 3.6 and later versions. Python string formatting. Purpose. Dynamically constructs strings by inserting values into placeholders. Improves code readability and maintainability. Methods. %operator. Oldest method, but still widely used. Placeholder, %s for strings, %d for integers, %f for floats, etc. Example. Name equals Alice. Age equals 30. Print, hello, %s. You are %d years old. Name, age. Format, method. More flexible and readable. Placeholders, index or name. Example. Print, hello, name. You are age years old. Format, name equals Bob, age equals 25. F strings, formatted string literals. Introduced in Python 3.6. Most modern and concise method. Placeholders, expressions enclosed in curly braces. Example. Name equals Charlie. Age equals 40. Print, F hello, name. You are age years old. Formatting options. Field width, specify the minimum width of the field. Precision, set the number of decimal places for floating point numbers. Alignment, left align, right align, or center align, caret. Padding, fill empty spaces with a specific character, example 0. Example. Name equals David. Age equals 35. Salary equals 50,000.5. Print, F hello, name .10s. You are age 02d years old. Your salary is salary .2f rupees. Best practices. Choose the method that best suits your coding style and project requirements. Use clear and descriptive placeholders. Consider formatting options to control the appearance of your strings. Test your formatted strings to ensure they produce the desired output. Additional tips. For more complex formatting, explore libraries like string.template or Jinjia2. Be mindful of potential security vulnerabilities when formatting strings with user-provided input. By effectively using string formatting techniques, you can create more readable, maintainable, and dynamic Python code.